A violin player riding on a slow train plays a 440 Hz note. Another violin player standing near the track plays the same note. When the two are close by and the train approaches the person on the ground, he hears 4 beats per second. The speed of sound in air is 340 meter per second. Calculate the speed of the train. Fine, now what is happening is, let's say this is my train and this is my observer. Right? He is not exactly an observer. Let's say this is my person 1 and this is my person 2 who is sitting in the train. Fine, let's say the second person is approaching with a velocity v, that is the velocity of train, and this guy is stationary. Now this guy, that is the first guy, listen a beat of 4 beats per second, right, or 4 hertz. Fine, so what actually the frequency that is heard by the first person? So it will be frequency that is heard by the first person will be equal to 440 plus minus of 4, right? So it will be either 444 hertz or 436 hertz. Now one thing, that first guy is stationary, second guy that is acting as a source for the first guy, and the source is approaching toward the first guy. So for him the frequency, the apparent frequency that will be heard by him should be more than the actual frequency. So if this is the condition, then 436 Hz has to be neglected and 444 Hz will be accepted. So F can be written as, that is the F that is heard by the first guy will be V plus V minus Vs by F naught, right? So I do have 444 is equal to 340 divided by V minus velocity of source, that is nothing but the velocity of train, into F naught, that is 440 Hz. So just solve this equation for the velocity of train. I get the velocity of train as 3.06 meter per second, or it is near about 11 kilometer per hour. That is the answer.